Hey everyone, welcome back to the channel Code with AKJ. Today is day 27 of solving Geeks for Geeks problem of the day. Today's problem is minimum cost of ropes. So the question says given an array ARR containing the lengths of different ropes, we need to connect these ropes to form one rope. The cost to connect two ropes is equal to sum of their lengths. The task is to connect the rope with minimum cost. So given example here, the array 4326. So here's the explanation. We can connect the ropes in following ways. First, they connected two ropes of length 2 and 3. So they have found the two minimum elements, and which makes the array 4, 5, 6. They have calculated the sum of these two values, and they again pushed it into the array. Again they found the two minimum elements out of it, and again they calculated the sum, and again pushed it into the array. And again took the two minimum elements, they have calculated the sum, and finally since the array element contains a single element, so finally they added up all these sums, and in this way we got the 29 value, and this is the optimized cost. So from this given explanation we can easily find out the brute force approach here. So the brute force approach here would be to sort this array and take the first two elements, which would be the minimum elements. We'll calculate the sum, we'll again push it into the array, we'll again sort the array, and again grab these two elements and again calculate the sum, and this will go on until or unless the array contains a single element. So let's try run this approach. So here I've written the array, and the brute force approach here is to run a loop, and inside the loop we'll sort the array, we'll grab the first two elements, we'll calculate the sum, and we'll push that sum into the array again, and we'll add all the current sum inside our answer variable. So here at the first iteration, the first two values would be our first two minimum elements. We have calculated the sum, which gave answer 5. We have stored it in answer variable. Again pushed 5 into the array. The array goes like this: 5, 4, 6. We'll sort the array 4, 5, 6, and we'll again calculate the sum 4 and 5, which will result in 9. We'll store this 9 in answer variable, and our answer variable gets 14. In this way, we'll push 9 into the array. We'll sort the array, which would result in 6, 9. We'll calculate the sum, and we'll store this sum in our answer variable. So finally, our array contains a single element 15, and here we'll stop the iteration. So finally, our answer variable will store the answer 29, which would be our minimum cost to connect all these ropes inside our array. So let's code this brute force approach, and let's see whether it gets accepted or not. So here's the code for the brute force approach we have discussed through this array. Here initially I have taken the total cost variable, and I have run a loop until or unless the size of the array becomes 1. I have sorted the array, I have taken the first two elements, I have calculated the cost, I have added this cost to the total cost, and I have removed the first element, which would be 2, and I have replaced the second element with our cost. And this will go on until or unless the size of the array becomes 1, and finally we'll return the total cost. So let's compile and run this. It's working. Let's submit. As you can see, this approach gives us time limit exceeded. So before moving on to the optimal solution or the approach, let's understand why this code gave time limit exceeded. So let's analyze the time complexity and space complexity of this algorithm. Here we are using a while loop which will run over the array, which would take O of n times, and inside the loop we have used sort function which will take O of n log times. So the total time complexity here would be O of n square log n, and the space complexity would be O of 1. But the expected time complexity here they have asked us to solve is O of n log n, and the space complexity we can use at max would be O of n. So the optimal approach here would be to use a data structure which would help us to find these two minimum elements. So the optimal approach here would be to use min heap data structure, where it helps us to find the two minimum elements out of the array. Initially what we will do is that we'll push all these array elements inside our min heap, and it will store in this way, where the first two elements from the top would be the minimum elements. We'll pop these two elements out of the min heap and we'll calculate the sum, and we'll again push this value inside our min heap. So this process goes on until or unless the size of heap becomes 1, and we'll calculate the sums and we'll add it up to our answer variable and we'll return the answer variable from there. So in this way the algorithms remain same, but the way we are using data structure would be different. Here we have used an external data structure which would take O of n in space complexity, and the time complexity here would be O of n log n, as the insertion of array elements inside a min heap takes O of log n times, and since we are inserting n elements, the total time complexity would be O of n log n. So in this way we have optimized the time complexity and space complexity as well. And let's try to code this approach and let's see whether it gets accepted or not. So here's the code for the optimized approach here. So here I've taken the size of an array. Here I've initialized the min heap. Min heap in C++ is initialized using priority queue, and I've pushed all the values of the array inside a min heap, which would take O of n log n times. And here I've taken a sum value which would store the final sum of all the connecting ropes, and I have iterated a loop which would run over the size of an min heap, and it will run until or unless the size of min heap becomes 1. I have taken the first two elements, I have calculated the length, added the length into our sum variable, and finally pushed this sum length value inside our min heap. And after finishing this while loop, we'll get our required result in our sum variable and we'll return this sum variable. So let's compile and run this. It's working, so let's submit. As you can see, this problem got solved successfully, and we have solved this problem statement in our expected time complexity and space complexity, where time complexity is O of n log n and space complexity would be O of n. So this is it guys for this video. I hope you liked my video and my explanation. So please give it a like, share with your friends, and subscribe to my channel for more such great content. I'll see you in the next video. Thank you.